Assalamualaikum and very good afternoon to Dr. Jindika. Today our company will be presenting to you about an issue occurs in offshore pipeline at West Africa, which is slugging, and the ways we mitigate it. Before we proceed, this is our content for today's presentation. First, we'll be talking about our company background, and then introduction to our project background, the case study and the objectives, the literature review, methodology, result and discussion, and we are from Rights Company, which is a new established company that has been operated since 2019, an independent and private company of consulting on the sectors of flow assurance engineering, pipeline management, and also we do international collaborations. We are one of the top provider solution for the flow assurance issue. Moving on to the next slide, which is our case study. It is based on the offshore pipeline in West Africa. So they encountered severe slugging in their pipeline, which leads to frequent shutdown, hence production loss. So they found that the cause of their pipe slugging is due to the flow instability. It includes low flow rate, oversized pipeline ID, as well as a hostile pipeline flow profile. So they have conducted a study on the potential mitigation on reducing or eliminating the slug. Our company also will be mitigating the slugging issue for this offshore pipeline. What we will do is we're going to use multi-flash software to analyze the fluidity composition, Olga to determine the flow profile throughout the pipeline, as well as fluent to determine flow profile at the rise base.
For the methodology of this project, we first defined the fluid composition within the multi-flash software, where we then export the file into Olga to define our flow parameters. We then created a pipeline model from the given case study, and we run the simulation for 2 hours. We then validated the results using visual analysis through ANSYS Fluent by using CFD simulation. And lastly, we provided the mitigation strategies using Olga software. So this is the fluid composition created in the multi-flash software. The amount for each component was provided in the case study file, and we created a phase envelope from this given data in order to define the flow parameters in Olga. So this is the pipeline model that was provided in the case study, which was then recreated into Olga, where we've added an extra 100 meter at the top of the riser in order to see the pressure fluctuations at the inlet of the separator. So after running the simulation for 2 hours, we were able to determine the flow profile throughout the whole pipeline, and it was found that at the base of the riser, slugging starts to occur. As you can see in the figure, at the base of the riser, the flow was in stratified flow, but at the top of the riser, the flow was in slug flow. And from the same simulation, we found that the pressure starts to fluctuate at the inlet of the separator after the 2500 second mark at the separator inlet. In order to validate the results, we recreated the model in ANSYS Fluent. So this is the geometry and meshing of the base of the riser. And by inputting the flow parameters into ANSYS Fluent, we were able to simulate the flow at the base of the riser, and it was found that the behavior of the flow is similar to the severe slugging process, which causes pressure fluctuations. So the mitigation strategies that we've come up with are gas lifting, ramp up, or topside choke. For gas lifting, we'll be injecting high pressure gases into the tubing in order to increase the fluid buoyancy within the riser. And it was found that the best place to do so is at the midpoint of the riser. Although this method is very effective in mitigating the problem, it is very costly and hard to do so. Another alternative is to do ramp up. This is a very cheap and effective way to mitigate the problem. This is done by increasing the valve openings in the pipeline, and by doing so we will increase the flow rate to the point where the pipe is completely filled with water, and when the pipe is completely filled with water there will be no slugs forming. And lastly, we have topside choke, where we reduce the opening of the valves at the top of the riser, therefore mitigating any slug formation. Although this mitigates the issue, however, you are choking the flow, therefore this is not the ideal solution because you will be reducing your production rate. So as a conclusion, all of the objectives have been met. The flow profile has been successfully determined through numerical analysis, and the numerical results was validated with visual analysis through CFD simulation and has come to a reasonable agreement, and the mitigation strategies have been proposed to mitigate the induced pressure fluctuations due to severe slugging. So that will be all. Thank you.